Welcome to the presentation of our Rube Goldberg machine.
Our group's objective was to crack an egg. Allow us to explain.
We've been working extra hard. Our project has a variety of simple machines which help us to increase mechanical advantage.
This is a hydraulic press in its most basic form. Pascal's principle states that the external pressure applied to a fluid is transmitted evenly throughout that fluid. The hydraulic press is made up of 2 syringes and a channel sealed off by plastic piping. Each syringe is a piston and a cylinder. When I apply pressure to this syringe, equal pressure will cause this piston to move. When the hydraulic press pushes this weight off of a platform, it'll fall and pull down on our compound pulley system, which is similar to a block and tackle. The first pulley is here. It allows the rope to slide back and forth, and another pulley is fixed to the end of the load or the plank. This portion of the pulley is fixed and not movable. When the compound pulley system pulls up on one end of the plank, it will convert it from a flat surface into an inclined plane. The weight will then roll off the end of the inclined plane, falling into the basket.
This is a first-class lever. When the weight from the inclined plane drops into the basket, the lever pushes up on the second lever, a second-class lever, and forces the gate to move. The fulcrum is at the opposite side of the force. The distance from the fulcrum to the location where the effort is applied is the moment arm. The moment arm is perpendicular to the direction of the applied force. If the moment arm is lengthened, we gain greater torque, because torque is the product of moment arm and the applied force. Once the second-class lever has been removed, the car is free to roll down the inclined plane. Using its wheel and axles, it overcomes inertia and friction, crashing into the screwdriver and allowing the leaf blower to turn on.
This leaf blower creates an artificial wind which will push against the blades attached to the lid of this jar, acting as a windmill. This construct is remarkably similar to that of earlier windmills because it is positioned horizontally. However, our windmill unscrews a screw instead of rotating on an axle. We've added oil to the lid of the jar to act as a lubricant and reduce friction. When the lid of the jar comes off, the rock will tumble out, pulling down on this end of the Class 1 lever. When the input force is applied, an output force will push up here, triggering this lever. This is the moment arm, and these 2 levers make up a compound lever system.
The upward output force of the first Class 1 lever becomes the input force for the second Class 1 lever. When the upward force is applied to the second Class 1 lever, it falls off of the table, pulling on one end of this pulley and yanking the stopper out of the spout, causing the water to flow. The falling water falls into the free swinging cups, causing it to the wheel to rotate on its axle. This design of the water wheel is similar to those of the ancient Roman engineers. The water wheel also acts as a winch, and as the water is filled into the cups, the rope winds around the outer rim, causing the bucket to fall. Without the weight of the bucket keeping it in place, the string falls. As the string is released, the gardening hoe acts as a Class 3 lever with a fulcrum here and the output force here. It also acts as a wedge to split the egg.
That was excellent. 2, 1. Wait, 3, 2,
No!
Three, two, one.
What?